what value makes the equation true? And so here's our equation. 2 over 5 is equal to something over 20. To do this, I want to show you two different methods that use multiplication to solve. So in the first one, this is a great strategy that any kid can use. I'm going to take the 2/5, and instead of multiplying, I'm going to use my repeated addition. I'm going to skip count. So I'm going to skip count on the bottom by 5s. 5, 10, 15, and I'm going to stop at 20, which is the number I want here. And now I'm going to do the same thing to my numerators. I'm going to skip count by 2s. 2, 4, 6, and 8. And what you've done is you've now created 3 more equivalent fractions. These are all equivalent to one another. So I can now say that 2/5 is equivalent to 8 over 20. Now, even though this is repeated addition, this is still multiplication. Multiplication just shows what I'm doing here, and I actually have 4 sets of 5. But I love this strategy because sometimes by 4th grade, we're not always as strong as we want to be in multiplication. So this one really helps. And I'm going to show you a second method, and this method I call property of 1. And why? Because anytime we multiply or divide a number by 1, it doesn't change. So just think about it. If I did 3 times 1, I still get 3. If I did 89 times 1, I'd still get 89. If I did 505 divided by 1, I would still get 505. So property of 1 is a way of still having the same value. And with fractions, when you multiply by 1, I'm still going to get an equivalent value even if the fraction looks different. So I'm going to do this the first time, and we're going to have more practice with this. So here's 2/5. And I want you to think over here. I don't have enough information for the top. But for the bottom, what could you multiply by 5 by to get to 20? So I know that 4 times 5 makes 20. So I'm going to now put a 4 in the numerator. 4 times 2 makes 8. The value of this is still 1. So yep, I am still multiplying by 1, but now notice I have 2 equivalent fractions. So this is another method that will work. You can either skip count or you can use property of 1. Let's hit pause and jot this down into your notes. Here's our second example. On the number line, points y and z represent fractions that are equivalent. So y and z represent fractions that are equivalent to the fraction x. So all of these have the same value on these lines. They're all at the same point, and each of these lines is the same length. They go up to 1. They're all the same size, but they have different fractions. What fractions do points y and z represent? So that's what I want to figure out. I want to know what this one is, and I want to know what this one is. So watch what I'm going to do here. I'm going to make this a little smaller, and what I'm going to do is I'm going to figure out how many pieces each line is broken up into. So the first one has a 0. Leave that 0 here. 0, I have a 1, 2, 3, and boom, even though it says 1 over here, I have 4 over 4. That's important. So I know my first one is broken up into 4 pieces. 1, 2, 3, 4. And now because I know my denominator, I can go back and put 4 as my denominator. So I know my x is equal to 3/4. Now let's go into the other ones, and I'm going to do the same thing. I'm going to count how many pieces. So here I have 1 piece, 2 piece, 3 piece, 4 piece, 5 piece, 6 piece, but I'm not going to stop till I get to 1. 7 piece, and here's my last piece, 8 pieces, or 8 over 8. So I know my denominator is 8. And so my second point, which is y, is equal to 6 over 8. Now let's get to z. And I'm going to do the same strategy again. So I have 0, and here I have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. Now, if you get stuck because it's very easy to make a mistake with counting, then by all means, you can still do the numerators here. And remember, I keep on going till I get to 1, and I have 12 pieces out of 12. Okay, but I'm really just looking for this one. So once you get good at this, you don't have to fill out the entire chart. I just wanted to show you that you could. I will say that when you have a lot of dots, you probably want to, just so you don't miscount. But here I have my last piece, which is 9 12ths. All right, let's hit pause and jot this down into your notes as well. Now we're jumping into our guided practice. So I want you to try this in either way you want. We're going to list 2 fractions that are equivalent to 5 6 with different denominators. And there are infinite possibilities here. So hit pause and try it out on your own. And then I'm going to give you 2 ways that I do it as well if you're stuck. Okay, so here are 2 ways. I'm going to split my page in half. So the first way is I can just take 5 6 again. It's my low lift way. I can just do this. And again, I'm just skip counting. So I'll start with my denominators. 6, 12, 18, 24. I've made 4 fractions. Wow. 5, 10, 15, 20. And I only needed to list 2. So on my line somewhere, I can list 10 12ths and 15 18ths. So again, I don't have to make this harder than it needs to be. This can be very simple. I don't have to write more than 2. But here you go. They just wanted 2 of them. Now, if you wanted to do property of 1, you can take 5 6 and literally multiply it by any number you want. So if you wanted, you can do by 10 over 10. Again, it's still 1, but because I get to choose a denominator, I can then just multiply by the same number on top. So here's an equivalent fraction, 50 over 60. I can choose 5 over 5. So remember, this has to be, I'm multiplying by 1 for property of 1. I have 25 over 30. And these are both numbers that are equivalent to 5 6. So I would have 50 over 60 and 25 over 30. Both methods work. Pick the one that you want. Some kids really love just coming up with numbers to multiply by using property of 1. And some kids would just rather stay, keep it simple and just use their KISS method. Keep it simple, silly, and just make a table. So let's hit pause and jot this down and just think for yourself, hey, was I able to make 2 fractions this easily? And if you weren't, now you can. All right, so let's go over the answer. Now, you probably saw that you had 4 12 shaded, 4 parts out of 12. And if you used this method to make 2 equivalent fractions, then literally if you kept it simple, you just picked the first 2, skip counting by 12s, 24, 36, 8, and 12. So you would have just gotten 8 over 12, 24, and 12 over 36. Or maybe you continued this pattern a little bit more and decided to get spicy and keep going. So you could have had any of these fractions that are equivalent on this line. As long as you were skip counting correctly and didn't make an error counting by 4s and 12s, then you've chosen 2 equivalent fractions. Now, if you chose property of 1, again, infinite possibilities here because you can literally multiply by any number to get an equivalent fraction. So for example, let's give ourselves some space here. If you wanted, you could have gone super simple and just done 2 over 2 and just gotten 8 over 24. If you had just chosen 1 over 1, it's not going to look any different, so I probably would not have done that. So you probably want to choose something, a numerator and denominator bigger than 1, so that this works. And again, you can be as simple or as spicy or as mild as you want. If you wanted to say 5 times 20, and maybe you want to do that, and you get 80 over 240, you can do that. So whichever was, these are 2 great methods that will work for you. Now, I do want to give you one hotspot, a really common mistake kids make here. And with this model here, the biggest mistake I see is kids who probably just skip count wrong. Like maybe they just make a silly mistake when they're counting their numbers. So just double check, take a second to go back and just check that you've skip counted correctly. And on this side over here, a property of 1, I've sometimes seen kids, I'm gonna erase this for a second. I've seen some kids do something like this, where they just think of a number, like in their head they'll go 6, and they'll go 4, they'll literally go 4 times 6 makes 24, and then they'll go 12 times 6 makes 72. And yes, these two fractions are equivalent, but this number sentence, my number sentence is wrong, because I'm not multiplying by 1. I'm multiplying here by 6. And I get it. It's like, but no, in my head, I multiply both of them by 6. So I know in your head, you actually went straight across. But when you write it this way, mathematically it's incorrect, because the 6, I would have 6 over 1. And so I wouldn't get that number. So just make sure that as you're expressing it, that this value you're multiplying by a 1, meaning it has to have the same numerator and denominator. Okay? All right, that's it for today's lesson. I hope you found it super helpful. Get more practice, and I will see you in the next one. Be well.